In this tutorial, we are going to cover question 7 from the DBE 2023. This is a June paper. The question reads as follows. The conductivity of three acid solutions A, B, and C as shown below is investigated at the same temperature. We are given the conditions here. For acid A is 0.1 moles per cubic decimeter, that is sulfuric acid. For acid B, 0.1 moles per cubic decimeter, nitric acid. And the compound C, acid C, is 0.1 moles per cubic decimeter of ethanoic acid. The brightness of the bulb in the apparatus shown below is used as a measure of the conductivity of the solutions. The acid solutions are electrolytes. Define the term electrolyte. 7.1. 7.1.1. So an electrolyte can be defined as a substance that dissolves in water to give a solution that conducts electricity. A substance that dissolves in water to give a solution that conducts electricity. Seven point 1.2. The brightness of the bulb for each of the solutions is compared. In which solution A or B will the bulb be brighter? Give a reason for the answer by referring to the types of acids. So we have got acid A and acid B. What we find is they've got the same concentration here. We know that concentration is one of the factors that affect the conductivity of a solution. So they've got the same concentration, but now here we've got sulfuric acid and nitric acid. So when we connect the two, which one is going to show more brightness? So here we'll find that we've got two acids, which is sulfuric acid and nitric acid. These two acids are different in the fact that sulfuric acid is a diprotic acid. It is a diprotic acid. Nitric acid is a monoprotic acid. What it means by diprotic is that it has got a 2H, which means it can donate 2 hydrogen ions per unit formula. This one is monoprotic. It can donate 1 hydrogen ion per unit formula. So it means that sulfuric acid is going to give us a higher brightness because the more hydrogen ions it donates, which means the greater the brightness. So here our answer is going to be H2SO4, which is our acid. The reason being that, like we have explained, sulfuric acid is a diprotic acid. That is, it donates 2 hydrogen ions per unit formula. So it means it donates more hydrogen ions than nitric acid. That's why it will have the bulb will have more brightness when connected in sulfuric acid. Then 7.13, in which solution B or C will the bulb be brighter? Give a reason for the answer by referring to the types of acids again, more or less the same similar questions here. For 7.1.3, we are comparing B and C now. So we've got B and C. Again, we find that B and C, they've got the same concentration, but now the acids here are different types. Now, the difference between these two acids, nitric acid and ethanoic acid, is in terms of their strength. So nitric acid is a stronger acid than ethanoic acid. Therefore, it ionizes completely to give a higher concentration of hydronium ions. So between B and C, nitric acid will give us a brighter bulb. So our answer is nitric acid. The reason is what we have given. Nitric acid is a strong acid. And what is a strong acid? That is, it ionizes completely. To give a higher concentration of hydronium ions. Higher concentration of hydronium ions. So that is the reason. So here we are differentiating them in terms of proticity. Here we are differentiating them in terms of strength. Okay. Now then we have got the question 7.2. 7.2 reads as follows. A hydrochloric acid solution, HCl, is standardized by titrating it against 25 cubic centimeters of a 0.04 moles sodium carbonate solution, which is sodium carbonate, the formula there. At the end point, it is found that 19.5 cubic centimeters of HCl has reacted. The balanced equation for the reaction is given here. Calculate the concentration of the HCl. There are two ways that you can work out that, but the easy way is to use the formula CAVA over CBVB is equal to Na over Nb. Okay, so we are comparing the ratio of the concentration. The concentration, the number of moles of acid over the number of moles of the base is equal to Na over Nb. Na over Nb is obtained from the balanced formula, from the balanced equation in our formula. In this case, we have got 2 for acid and 1 for the sodium carbonate, which is our base. So we can substitute here. We are calculating the concentration of HCl. So we can substitute here. Ca is our unknown. So we are going to have Ca multiplied by volume of acid. The volume of acid is 19.5, which is 19.5 cubic centimeters over the concentration of the base is 0.04 multiplied by 25 cubic centimeters. You can choose to express your volume in terms of cubic decimeters. It's all fine. But in this formula, you are free to use cubic centimeters because the cubic centimeters will cancel out. Okay, this is equal to number of moles of acid in terms of the balanced equation is 2 for acid over 1 for the base. So over 1. Then we can work out the concentration of the acid. So concentration of an acid makes Ca the formula, we are going to have 2 over 1, of course, multiplied by 0.04 multiplied by 25 over 19.5, which we can calculate in our, we can input that in our calculator. So this is 2 by that, so this is 2 multiplied by 0.04 multiplying 25, this is over 19.5. I'm getting 0.1025. So this is 0.1025 moles per cubic decimeter. So that is the concentration of the acid. Question 7.22. Question 7.22. Suppose a few drops of water were present in the burette before it was filled with the hydrochloric acid solution. How will the volume of the HCl solution needed to reach the end point be affected? Choose from greater than, smaller than, or remains the same. Give a reason for the answer. 7.2.2. So here we are told that we are given that hydrochloric acid is standardized by titrating it against 25 cubic centimeters of sodium carbonate solution. At the end point, it is found that 19.5 has reacted. Now, if we had water present in the burette, when we are titrating, remember we use a burette. If we had water in the burette before it was filled with the hydrochloric acid, what effect would it have on the volume of the HCl? So the volume of the HCl would be greater. It would be greater than what is the reason for that? Because the few drops of water will dilute the hydrochloric acid, and therefore the greater volume of acid will need to neutralize the base. So the first few drops would be of water would dilute the HCl, and therefore would need more acid now to neutralize the base, which is our sodium carbonate. So we write the reason here that the few drops of water will dilute the acid, will dilute the HCl, and therefore greater volume, which is our answer here, greater volume of HCl is needed. To neutralize the sodium carbonate, or you call it the base, to neutralize the base. So that answers 7.22. Let's move to the next question. A concentrated household product, ChemClean, contains ammonia. Ammonia is NH3. Contains ammonia as the main cleaning agent. To determine the amount of ammonia present in 1 cubic decimeter of ChemClean, the following procedure is followed. 20 cubic centimeters of ChemClean is added to 250 cubic centimeters 25 cubic centimeter flask. The flask is then filled to 250 cubic centimeters marked with distilled water. So the procedure is shown here. We've got 1 cubic decimeter. This is 1,000. This is 1,000 cubic centimeters. So 1 cubic decimeter is, we take 20 cubic centimeters of that and then we dilute it. We add it to 25 to 250 cubic centimeters when we dilute it with water. Then this diluted solution is titrated against the hydrochloric acid solution of the concentration as calculated in 7.21. So we found that the concentration in 7.21 in what we answered earlier is, how much was that again? 0.1025. So this is 0.1025 cubic centimeters. So we know the concentration of that acid. So the diluted solution is titrated against the hydrochloric acid of the concentration as 0.1025 cubic decimeters, okay, per mole. Then during the titration, 22 cubic centimeters of the diluted ChemClean solution is neutralized by 18.7 cubic centimeters of the HCl. The balance equation for the reaction is given here. And then calculate the mass of ammonia in 1 cubic centimeter. So what is the mass of this ammonia here that we have taken earlier? So what is the mass of that ammonia is what we are calculating in 1 cubic centimeter. So we took from here, we took 22 cubic centimeters of the dilute, and then this was neutralized by 18.7 cubic centimeters of HCl. Now what we need to find first is to calculate the number of moles that neutralized our ammonia. Okay, the number of moles of HCl, hydrochloric acid, that neutralize the ammonia. So let us find the number of moles. We are answering 7.2.3. Number of moles of HCl. Okay, the number of moles of HCl is concentration times volume. We get this from the formula N is equal to, concentration is equal to N over V. So we get this from concentration is equal to N over V. So when you make N the subject, N is equal to the concentration times volume. Now we are given here that the concentration is what we got earlier, which is 0.1025. Let's take it as well like that. Then we multiply that by the volume. Now our volume here must be in cubic decimeters. We are given 18.7 cubic centimeters. So that is 18.7 divided by 1,000. Because there are 1,000 cubic centimeters in 1 cubic decimeter. So we want to change that to cubic decimeters. So that is 0.1025 multiplied by 0.0187. Okay. And the answer we get there is the concentration of the acid. So let's work out that in our calculator. So we have got a 0.125 by 1025 rather, 1025 multiplied by 0.0187. Now I'm getting 1.916. So that is 1.916. Let's take the maybe to 3 decimals. 675. Okay, I will take it all of it. 675 times 10 to the power negative 3. So now we want to find the number of moles. So once we get the number of moles of hydrochloric acid that neutralize, according to the ratio here, the number of moles for the ammonia NH3 is 1:1, because the ratio is 1:1. So the number of moles for ammonia that reacted, number of moles of ammonia, which is NH3, in 22 cubic centimeter, because remember it's 22 cubic centimeters of ammonia that diluted that. So this is also going to be the same according to the ratio. The ratio of ammonia to acid is 1:1. So it's going to be 1.91675 times 10 to the power negative 3. You can choose to round it off to 2 decimal places and so on. Now, what we are given here is in 22 cubic centimeters, we had 1.9167 moles. These are moles. Now we want to find how many moles were there in 250. How many moles were there in 250 in the whole flask? So which means we are going to have the number of moles of ammonia in 250 cubic centimeters is going to be, now we are going to have how many 22 cubic centimeters are there. So it's 250 divided by 22. Then each one has got 1.9. So we multiply that by 1.91675 times 10 to the power negative 3. Now we are going to have this. Let's calculate it now. Right, so we are having, this is our number. We multiply that by 250 over 22. So our answer is 0.022. Let's put it that way. 0.022 moles of ammonia in 250 cubic centimeters. Now, so which means now let us find the mass of this. So what was the mass of this? This mass is the, remember we took the 20 and diluted it in here. So we want to find how much was here. The 20 cubic were added here. So the number of moles that we have here in 250 is the same as the one in 20. So we want to find how much was added there in terms of mass. So therefore, let us calculate the mass of that ammonia. So the mass of this ammonia NH3 in 20 cubic centimeters is, from the formula N is equal to mass over molar mass. So we are going to have here mass being equal to number of moles times molar mass. So it's going to be number of moles times the molar mass of ammonia, which is NH3. Now, how many moles are here? 0.022 multiplied by the molar mass of ammonia. The molar mass of ammonia, we have to get it from our periodic table. We've got a periodic table. NH3. So NH3 is nitrogen plus 3 of hydrogen. So nitrogen is 14 plus 3 of that one, that is 17. Okay, so we are going to multiply. This is going to be 14 for nitrogen and 3 for hydrogen, so that will give us 17. So our mass is we are going to multiply that by 17, right, which is equal to enter that in our calculator. So 0.022 multiplied by 17 is going to give us this 0.374. So that is 0.374 grams. Now from there, now we want to find what will be the mass in 1000 cubic centimeters. Remember, this is for 20 cubic centimeters. So in 1000 cubic centimeters, how much would that mass be? So therefore, we can go on and say here the mass, therefore, which is now the final part of the question, the answer, mass of ammonia in 1 cubic centimeter. So therefore, the mass of ammonia in 1 dm3. So here we have got 0.7374 in, this is found in 20 cubic centimeters. So how much would we find in 1000 cubic centimeters? Remember, we said 1 dm3 is 1000. So we are going to again have a 1000 over 20, then multiply that by 0.374 grams. So let's work that one out in our calculator to give us the final answer. So I've got 0.374 right here. All we need to do is to multiply that answer by 1000, which is like a 50, 1000 over 20, and the answer is 18.7. So we are going to get 18.7 grams. So the answer to 7.23 will be 18.7 grams. 7.24, will the pH of the solution at the end of the titration be greater than 7, equal to 7, or less than 7? In other words, is it going to be greater than 7, that is basic? Is it going to be alkaline? Equal to 7, is it going to be neutral? Less than 7, is it going to be acidic? So this is based on hydrolysis now. So here we find that we have got a sodium chloride that is formed when we neutralize ammonia with hydrochloric acid. So we got NH4 aqueous plus Cl2. So we know that the anion of a strong acid, it does not take part in hydrolysis. So Cl is not going to take part in the hydrolysis. And then we will have ammonia. So it's ammonia that is going to react in the water. So here, what we are going to have, 7.24. Maybe before we answer this question, let us give the reason first. Write down the relevant equation as motivation for the answer. So I'm just going to write the relevant equation here below. So our equation, we are going to have ammonia which is NH4 plus, this is an ion, will react in the water. Remember, an acid and a base, they will give us, the aqueous, they're in water, they will form water as well. So we are going to have reacting in water, it is aqueous. And then what are we going to get from there? Now what we are going to get there is, we have ammonia is a positive. The easy way is just to say, when you see this is positive, it is going to donate an H. There's an extra H there, so the H will be donated to H3. So this is going to be H3 plus. We are going to form hydronium ion. And then from NH4, we are going to have an ammonia NH3 there. So in other words, the ammonium will donate to the water. Water is acting as a base now here, which receives that proton. So we are going to have hydronium ion plus the ammonia. Now the formation of this hydronium ion, this is an acid. Now this is the one that will cause the solution to be more acidic. This is an acid. And since it is an acid, therefore it means that our not greater than 7, our solution now is going to be less than 7. So our answer to that will be less than 7. The reason being that we have formed an acid over here when the ammonium, this ammonium, is formed in water. And therefore ammonium, there's hydrolysis, there's a reaction between ammonium and water to give us H3 plus. Okay, so that explains. So the formation, maybe we can add here, the formation of H3O plus, okay, causes the solution to be acidic. Okay, so that explains the answer to 7.24. So that's it for this question. There are 21 marks. I hope you learned something. We'll see you next time. Bye.